Alright, hi guys, I hope this works and you can hear it. Trying our video slightly different this week. I'm recording these on my iPad so I can write with my pencil because there's a lot of writing involved this week and it would take me about 27 hours if I attempted to do it all on my laptop. Hey, so you can clearly see that there are going to be a couple of videos this week, and that's just because there's a couple different topics in this section. I thought it'd be easier to chunk it into a few different shorter videos rather than one big old video. Alright, so we'll start. This first one is just solving equations. Okay, so we talked earlier about how we'd be going from solving equations with two variables to solving equations with many variables, and that is when matrices really become our best friends. Even looking at this one, if we were asked to solve x minus 2y plus z equals 7, y minus 2z equals negative 7, and z equals 3. When we say solve, we need the value of x, y, and z to make all three of these true. Okay, what's super nice, I think that's gonna work, is that they've already solved for one of them for us. Z equals 3. So we can simply start by back substituting z in to the only other equation that has a z and only one other variable. We could try and put it into equation 1, but we'd still be left with two variables. So I'm going to put it here into equation 2. So we get y minus 2z, z is 3, equals negative 7. All right, or y minus 6 equals negative 7. So y equals negative 7 plus 6, which is negative 1. Okay, so there we solved for y. We still don't have x yet though, so now I'm going to use this first equation. I'm going to use colors. This is fun. So I get x, I should do this, fun, minus 2, y is negative 1, plus z equals 7. So we get x plus 2 plus 3 equals 7, x plus 5 equals 7, or x equals 2. Okay, super important for you guys when you're answering these things on the Schoology quizzes. I don't actually know what they're called. It's not an ordered pair because it's not a pair, but we write it in alphabetical order. So our answer would be 2, negative 1, 3. That is the solution, the x, y, z values that make all three of these systems true. Okay, I left a blank in case I needed it. All right, so that's just solving systems. We're going to start learning a new method for solving systems though, called Gaussian elimination. Okay, it's named after Carl Friedrich Gauss. It's actually a very famous mathematician. He came up with a lot of stuff. So when we're thinking about using Gaussian elimination, our first one was substitution. Now we're thinking about elimination. There are some things that we can and can't do to kind of stay on the safe side as far as what's mathematically allowed, because I know sometimes you guys like to do weird stuff that's not actually math. Let's stick more or less to these rules. So the following operations produce an equivalent system of linear equations. What's important? It has to be equivalent. Okay, what we can't do is all of a sudden have something entirely different than what we started with. So things that you can do is interchange or switch any two equations of the system. Okay, you can multiply or divide one of the equations by a non-zero real number, as long as you do it to every part of the equation. If I want to multiply every part by 2, go for it. And you can add a multiple of one equation to any other equation in the system. Right now, you may be a little confused as to what these mean. I'm going to go over them, but these are really the only three things we're going to be doing when we do Gaussian elimination. Switching two rows, multiplying by a constant or dividing, and adding a multiple of one equation to the other. Okay, so let's say that we were asked to solve this system. Obviously, significantly harder than the one we saw before because we don't have one of the variables solved for us. And we have 3 different variables here, which is going to make it a little bit more difficult. Okay, one place that we can start, so we can switch any of the two rows if that helps us. We can multiply a constant to one of the rows, or we can add a multiple of one row to another. So I think like we think about the whole elimination, right? I see I have an x, a 3x, and a 2x. To eliminate a 3x and an x, I'm going to multiply this entire first row by -3, right? Because then I can use that elimination. So we get -3x, right? -3 times x, -3. I keep forgetting you guys can't actually see me, and I'm using like a lot of hand gestures right now. -3 times -2y, -3 times z, and -3 times 7. So now I have -3x plus 6y minus 3z equals -21 for my first row, right? That was the second rule. We can do that as long as I multiplied every single term by that same constant. What we couldn't have done is just multiplied the x term or the y term. Got to multiply it all. Okay, so what's nice is now I have multiplied the first equation by -3, and I'm going to add this result with that second equation. Right, this is just like that elimination we looked at 2 weeks ago. So -3x plus 3x is gone. That's the entire reason we did that. 6y plus -5y is just positive 1y. -3z plus z, -2z. -21 plus 14, -7. Okay, so what I'm looking at now is that I have the equations. First equation, x minus 2y plus z equals 7. And now I've simplified my second equation. I have y minus 2z equals -7, right? My second equation there. And my third one is still the same there. I got 2x minus 2y minus z equals 3. Okay. All right, now let's look. Anything else that we could do that would help us simplify things down? I can multiply an equation by a constant, I can switch two equations, or I can add, that's what we did here, was added a multiple of one equation to the other. Well, I see that I'm almost rid of one specific variable. What if I multiply now, instead of up here, I multiplied by -3 to cancel out my x's. Can I try now multiplying by -2? Because then I have a positive 2x and a negative 2x. And I'm going to go from here. Maybe like arrows will help. I went this way. Now I'm going to go this way. Okay, so multiply that top equation by -2. -2 times x, -2x. -2 times -2y, -2 times z. And my third equation now. I have 2x minus 2y minus z equals 3. And when we add these two equations, we get 0x, right, the entire point of doing that, 4y plus -2y, -2z minus z. I should be more consistent with my 2's. -14 minus, or sorry, -14 plus 3. I had to really think about what that was. All right, so now we've simplified equations 2 and equations 3 to not have x variables. So what I have now is x minus 2y plus z equals 7, right? That was my first equation. X minus 2y plus z equals 7. I simplified equation 2 to have no x variables. Where is that? Up here. I simplified equation 2 to have no x variables. So we have y minus 2z equals -7. And then I simplified equation 3 to have no x variables. 2y minus 3z equals -11. And what we've done is we've gotten rid of those x variables in the first, in the second two equations. All right. Okay. Now can we even get rid, so what we did is in the last two equations, we got rid of x's. What should we try and get rid of now? I mean, we can go for whatever, but it seems like a logical thing to go in alphabetical order. Oh, that didn't work. Okay, so we went this way. Now I'm gonna go this way. All right, I got rid of my x's, so I'm gonna try and get rid of y's. So if I look at my last two equations now, that I've simplified the x's, I have no x's there. I have a y and a 2y. It'd be nice to eliminate the y's, so I'm going to multiply it by -2. So my second equation there is -2 times y, -2 times -2z, -2 times 7. And then my third equation, okay, if I add these two, I got -2y plus y, well, gone. Again, the whole point in doing that. And now I have 4z minus 3z. Z equals 3. Okay, so now what we're looking at, let me arrow again this way. Now what we're looking at is our first equation, x minus 2y plus z equals 7. Second equation, still there, y minus 2z equals -7, and z equals 3. Now, this is the exact same equation that we looked at in example 1. If we scroll back to example 1, exact same equation. We just had to take quite a few more steps to solve for z. We weren't given that first step of having z solved for. And the main thing that we did here was 3. We added a multiple of one equation to any other equation in the system. I added a multiple of -3 times the first row. I added a multiple of -2 times the second row. I added a multiple of -2 times the second row again until we got down to solving for z. Okay, so that's what Gaussian elimination is. Personally, I find it much easier to do in a matrix, but if you like doing it this way, that's fine. Okay, we'll go over one more example for this video of solving a system, and we're going to see that we will come out to a place where we have no solution. Thinking about when would we have no solution? Well, times when we have no solution is if you got something like 7 equals 4 or 0 equals 16. Something that's not true means we have no solution. Okay, all right, so let's think about solving this system. What's really nice, then when I immediately look at this, I'm going to find a different color. I just got distracted, sorry. I like blue. When we look at this, I already see that my first two equations have an x and a -x. So if I add the first two equations, I can already eliminate, right, that's why we call it elimination. I can eliminate the x variable. Whole point is we want to eliminate variables until we get down to solving for one of them so that we can back substitute it in. Okay, so if I add the first two equations, x plus -x, x's are gone. Woohoo! -3y plus 2y is going to be -y. -5z plus z, -4z. And 4 plus 3, 7. Okay, so arrow, it went this way. Now we're going to go this way. All right, so first equation is still there. I have x minus 3y plus z equals 4. My second equation, I've eliminated the x. -y minus 4z equals 7. And then my third equation, 5x minus 13y plus 13z equals 8. Okay, all right, so thinking what can we try and eliminate now? We should try and eliminate the x's still. So I'm going to multiply. Think about it before I say it. What would you do? Hopefully, we're going to multiply this first equation by -5, because then I will have a -5x and a positive 5x from my third equation. So we're going to go down to the next screen. So I have in my first equation multiplying everything by -5. -5 times x. negative 5 times negative 3y, negative 5 times z, and negative 5 times 4. Can you guys imagine how long this would have taken if I was trying to write this on my computer? Plus 13z equals, where am I at? 8. All right, third equation. So multiple negative 5 of the first equation and third equation, add them, whole point, eliminate the x's. Negative 5x plus x, plus 5x, 0. Negative 15y plus negative 13y, we're going to get 2y. Negative 5z plus 13z, we're going to get 8z. And negative 20 plus negative 8, negative 12. Okay, so now we are here. So my first equation, x minus 3y minus z equals 4. My second equation that I eliminated the x from, negative y minus 4z equals 7. And now my third equation that I've also eliminated the x from, 2y, I don't feel like erasing. 2y plus 8z equals negative 12. Awesome, we eliminated the x's from the first two equations. Now let's try to eliminate the y. So I see I have a negative y and a positive 2y. So I'm going to multiply that second equation by 2. Because then I'll have a negative 2y and a positive 2y. So if I do 2 times negative y, I get negative 2y. If I do 2 times negative 4z, we get negative 8z. If I do 2 times 7, we get 14. Okay, so that's my second equation there. Now I have 2y plus 8z equals 12. Let's add our equations. Negative 2y plus y, gone. Negative 8z plus z, gone. So we have 0 equals 26. This is where we see why we would have no solution. Was that supposed to be a negative 7? Nope, I'm good. Oh, this is where it went wrong. Negative 12. Sorry, this was a negative 12. I just copied it down wrong. Negative 12, but still negative 14 plus 12 is 2, and 0 also does not equal 2. So we have no solution. Okay, so solving equations with Gaussian elimination. If you don't like this, that's okay. We're gonna go over elementary row operations. It's not any more simple. It's just simply, I think, more organized, but you're doing the exact same thing. So this will be the end of video 1 of solving equations. And then our next video will be using matrices to solve these.